Next up, he is the CTO of Luxoft, and he's also co-founder of the Crypto Valley Association. Ladies and gentlemen, Vasiliy Suvorov.
Hi, everybody. Super excited to be here, and thank you for coming and saving the energy. I hope you've been initially inspired by Professor Buchanan, who talked about homomorphic encryption, all kinds of different things. And I'm really grateful to Daniel, who set up the stage, I guess, for my talk. So as you've seen, identity has all kinds of exciting, interesting applications. But is it limited to only certain startups or certain companies who can build applications on identity? Can we actually use the powerful notion of digital identity for building applications on blockchain in different areas, in government, in medicine, in logistics, and all kinds of different applications? So I would like to share with you information about what's going on in the technology world, what are the standards, what are they based on, how to use them, how to combine them with blockchain. So I usually like to start when we talk about complex technology topic by maybe seeing if there is some intuition in the language that we use every day. And if you look at different dictionaries, the Oxford Dictionary, Cambridge, and Merriam-Webster, it turns out that identity is a very, very important concept in our language, right? It does allow us to communicate efficiently about things, because if we cannot differentiate between what things are they the same? Are they different? Do they have certain characteristics, right? It's very, very difficult to discuss anything and get things done. In mathematics, for example, we also use all kinds of interesting notion of identity in a technical way. So it is pervasive. It's something that we rely on every day. Okay. I usually have problems with clickers. Okay, there we go. So now, switching to blockchain, just warming up a little bit. So the diagram that you see here, and those of you who are building blockchain protocols will forgive me for giving you, compressing all the complex notions of consensus and everything else into very few simple steps. So it doesn't matter which blockchain solution you're building or DLT technology you're using, you're taking your secret key and your public key, right? You generate some sort of transaction or change of state. You send it to your DLT technology with that signature coming from your secret key, right? Then transaction goes into verification, which is based on history. And in the history, you store, the addresses, the signatures, and everything else, right? So essentially, it all depends on your secret key. So, right? So this is your identity. This is how we know it's coming from the right person. It's different from other transactions. This is how, and then it's stored in the history, right? Which becomes an alterable part of a blockchain technology. So, we need to manage that. We really need to manage that. So it doesn't matter which application we're building, we really need to think about what is the robust way to manage identity, and we need to rely on some proper technology to do that. Obviously, blockchain is already a bit confusing. We have a bunch of different systems for permission blockchains, for public blockchains, and new blockchain protocols seem to come and mushroom every day. So it does not help application developers who want to understand which one do I use. So it's very good that there are organizations out there that get together, share their ideas, and pick holes in each other's arguments, because identity is a very important topic, to define how to manage identity and how to decentralize identity, right? Because for us, it's not just identity, it's decentralized identity, right? That's the whole powerful notion of blockchains and DLT technologies. And there's an organization called Decentralized Identity Foundation. There's, I think, 56 companies there. Just last year, there was 20. So it shows you they're getting some traction, they're getting some movement, some big companies like Microsoft, Accenture, some startups like Aetherium and others. And they are actually also working on more formal standards organizations such as W3C. There's a couple groups there. One is called Credentials Community Group. The other one's Verifiable Claims Working Group. And in my presentation, we will look at what they do and what they work with. So the first key enabling piece of technology that you should consider using in your identity applications is decentralized identifiers. So the design goals that were set for decentralized identifiers was to basically enable self-sovereign identity management, the privacy. So it's not easy to track you. It's not easy to correlate how you're using different services. Simplicity, extensibility, and all these other different wonderful things. So it's based actually on a very simple notion. So you have an identifier that you see here on top. which says DID, and then says example. Example is a method. We'll talk about different implementation. And that gives you a number, basically your unique identifier within that system. What's important is that number then points to DID document. DID document is a simple, JSON linked document, linked data format, or JSON LD. And then it defines number of different fields. Like, okay, so for this specific identifier that sits on the system, right, implemented by some sort of technology, these are the keys, public keys that are known for this person, and it can be a number of other things, such as the end services you can go to talk to this identity, to the agent, which we'll introduce later, and other different things, how this person or machine or organization want to interact with the outside world. This is how you know how to deal with that. Okay. So it's important to understand that, okay, this is just enabling building block. But for the system to function, you need to make certain assumptions and look at the players in the ecosystem. And what's interesting about this compared to PKI technology and some other technologies is that basically you define the issuer, somebody who creates the claims or attestations about your identity, your age, your address, qualifications, and so on and so forth, right? So they send these claims to a holder. So holder is basically a person, a thing, or organization. And what they need to do, they just store these claims. They store these attributes of their identity, and then they need to trust the repository that they're using because they are the holder. It's a self-sovereign identity concept to be secure, right? Then, if they need to prove to somebody a certain age, or they're able to drive a car, or they have a job, and so on and so forth, they go to somebody called inspector verifier, who requests a claim, and then you share information directly, right? So you own it, and you consent, you know why you're doing that. So you send that information there. And then the inspector verifier basically trusts that because of technology, that this claim has been signed and comes from the issuer, authorized issuer, right? The other important thing is the holder, when he or she receives the claim, actually trusts that the issuer gave them a correct credential, and they can also revoke the credential if it's no longer valid, right? Finally, remember the piece where the DID pointed to DID document where we could discover things about the holder. If you want to make it public, you can with identifier registry, right? And we trust that the registry is incorruptible and talks about correct ownership. In other words, the public keys are correct. If public key has been stolen or revoked, a new record needs to be in, which says, okay, this is now the correct key, and so on and so forth. So what happens here compared to other techniques is that previously you need to rely on identity provider to do both things on your behalf. Create and store a claim or attestation or identity attribute, and then provide it to somebody who wants to check it. Now we decouple that, and so you can work with a number of different issuers and be in charge of your own destiny and be in charge of your own data, where you provide a number of different, inspector verifiers. So this is a very, very key concept for decentralized or self-sovereign identity. So, kind of building on that. So how can you use it? So, we have a DID, and we have our traveler, maybe Bob, who worked with DMV. DMV is a agency in the United States that verifies and issues driver license. And he wanted to use the information from the driver license to prove he's over 21 years old, so he goes to a bar. In some United States, in the United States, they verify that he's above a certain age, so he doesn't want to reveal that, he's Bob, he lives somewhere, his date of birth and things like that. So rather than presenting his driver license, he will provide a claim which says that he's over 21. And there is, as you can see, there is something called proof in there in green that allows the bar to go ahead and verify it, right? So they will make sure that this public key and this proof, this signature is coming from DMV. It's now an agency. They trust them. So okay, it's over 21. So that's great. Easy. Obviously, but I mean, this is all theory. This is just standards. So who is using that? It turns out that because of Decentralized Identity Foundation, there are multiple different methods and multiple different implementations of this technology. As you can see, some of them here, this is a growing list. So Uport provides implementation. Sovereign, there is something links to Bitcoin, IPFS. There is emerging standards on top of Ethereum as well. And how does this work? It's actually very, very simple to use. And that's why you guys should use it if you build applications for identity on blockchain. You take the DID, you basically build connection to your favorite decentralized identity system like Uport, ERC725, and so on and so forth, or Sovereign. And then you use a driver, right? So even if you have some other users who are using different system, you just use the driver to translate the method call into the identity provider and get the DID document from them. They will translate from their system to the DID format, which actually makes your life easy and portable and less connected to a single company. So when we talk about Ethereum, obviously, Ethereum is a very, very important player. There's lots of applications being built on Ethereum. And of course, they understand they need an identity layer. There's essentially two efforts out there. They somewhat competing, but I think there's a lot of dialogue going on. There's something called ERC725 and related standards ERC735. ERC, for those of you who don't know, stands for Ethereum Request for Comments. Which comes from internet world, basically. The idea of these comments is that it's a technical standard that people propose to the community. So with ERC725, it's very similar to ERC20, the token standard, that it defines a set of methods and data fields whereby you can do some attestations by different providers, you can manage your keys, and everything happens on-chain, right? So that's very important to understand. So basically, smart contract, you can think of it as a class, right? It owns some data, and it owns some methods to manipulate that data, but all data is stored on blockchain and visible to everybody, right? So your public keys, verifications of your claims, everything else is basically visible for everybody, but it does allow you to build interesting applications where some dApps based on a smart contract can verify from the other smart contract that certain things are allowed to happen and good, right? So that's that part. It's a developing system. Uport, on the other hand, sort of actually tries to combine two worlds. They use, and the important thing to say about ERC725 is that your identity is basically a smart contract, right? With Uport, however, the approach is somewhat different. You have a complicated system of smart contracts with some proxy smart contracts and so on and so forth that help you manage your keys and recover your keys and call to other smart contracts on your behalf. But basically, all the claims, everything else is stored outside of Ethereum on mobile app today, and it's very easy to connect to it. They also defining a standard ERC780, which is similar to ERC735, to store claims on-chain if that's what's required, right? So they're really building universal identity layer for both on-chain and off-chain solution focused on all kinds of different use cases. But there's a lot of dialogue going between the community, so it's a good thing. You know, from our standpoint, again, if you're using DID, there's drivers that will transform between those two different systems. So if you use DID, you're safe, right? So that's easy for you to do. Now, so let's talk about Sovereign a little bit. So you've heard about Sovereign from Daniel Geistarger. Hopefully, many of you have heard about them before. Just to explain this thing, so Sovereign technology, Sovereign is a public permissioned ledger, like utility ledgers that just focused on managing identity, managing those keys. If you recall my initial model, how people trust each other from issuer to the holder to verifier, there's something called registry. So Sovereign is that registry, right? So because basically the question is, if I have my DID, how do I discover, connect the DID document about my public keys, about my endpoints for you to interact with and talk to? Well, you need a registry for that. And of course, you can use Ethereum as a backend or a database as a backend for it. Now, the problem is, how did this DID get there? Well, who puts them there? How do you know this DID is coming from, city of Zug? Or is it coming from police office? Is it coming from a company? Is it coming from a specific individual? you need to create a framework of trust, right? And there's this concept called web of trust, where people kind of vouch for each other and create claims about each other. So it can create trust, but trust has to start somewhere. And the way Sovereign approached this is said, okay, actually we have to have a governance structure that consists of the board, and that consists of trustees that are, and that consists of stewards that are running the nodes. And for us to onboard stewards to the system, we need to understand who they are. They need to have an identity. We need to be able to trust them. They need to have the right motive for being part of the system. So there's a governance structure to onboard network nodes on the system. And then these network nodes, in their own turn, can then basically create the ID records on the system and create identity for people. And because you know who they are, and they have a motivation to be on the system, that basically serves as your trust layer, right? This is how you build it from ground up. And because it's a separate ledger, you can kind of manage your risk. You can see where you distribute your trust, who runs it, where, and deal with problems, right? So, of course, it's possible to build with other technologies, but because you want to jumpstart it, you want to run it, it's a lot better to maybe start with this solution. But obviously, we'll see how this works. So, other interesting concept about Sovereign, in the next slide, I'll talk about the underpinnings that create this technology, is that basically there's a concept of agents, right? Because it's fine and good if I have my cell phone and I have my data on it, but what if I'm not online and somebody needs to interact with me and verify my identity, right? So this is where agents come in. And you have basically a couple different agents. You have at the edge layer the app type of agent and some agent that will represent me in the cloud. And you have, of course, can have multiple agents representing you, and they serve as a gateway for interactivity with you, for understanding who you are and allowing you to work with other people, basically, right? So, and that's why you need service endpoints and DID document. The other interesting thing that this technology allows, because it's based on something called attributes-based credentials, is zero-knowledge proof. So, if you have an issuer, you have owner of the data, and you have a verifier, basically, I don't have to reveal all the information that I have from the issuer to the verifier. I can provide information about me, but I can hide the data and will provide a zero-knowledge proof that the verifier will check and make sure that, yes, cryptographically it makes sense, it's coming from the known source, so we're satisfied with it. So it's also a very, very important thing. And I guess the great thing about this technology is that from the source code standpoint, it's open source. It's part of Hyperledger Alliance. As you know, Hyperledger incubates all kinds of DLT technologies out there. It's called Project Indy, so you can take it and you can use it even without Sovereign in your own network if that's what you want. But you can also contribute, you can understand the technology and things like that, so it's a great thing. So, so this part is probably just an example of how that actually works in a real setting, just to put it in the context. So let's say you have a traveler, and travel will have different DIDs, because we want to have a pairwise relationship. Why do we want to do that? Because we don't want to leak privacy. I have a slide that talks about that too. So basically, I travel on behalf of the company, and I have a relationship with that company with one DID. So I have a claim from them, and I'm authorized traveler from that company. I go, can check into a hotel. They can verify that I'm from IBM, so they give me good rate. I'm not just pretending, and they know how to bill me, so all automatic, all's great. But with hotel, maybe actually, I don't want them to track me across other usages, so I use a different identity, right? And this is my kind of a session key, if you will, right? So I have a special session with them, and they trust it. They know who I am, but the data is coming from my company. I'm only giving the information, not my job title, when I was hired and things like that, but just I'm traveling on behalf of the company. So I provide the zero-knowledge proof, and they can accept me without tracking me and understanding where I go next. So next I go to rent a car, and I'm using yet another part of the claim from the company to prove who I am, right? Maybe my date of birth that's provided by the company, maybe the fact that I have credit, other different things. So yet again, I have another identity with them, and then I use zero-knowledge proofs to reveal information that's only specific to this guy. And the screenshots there basically give you some protocol logs, how you interact with the system and what it does. So we talked about, well, this whole system has been built to enable privacy and protect you. But you know, it's not a given, because if you look at your identity information, your government ID, your passport number, your address, date of birth, zip code, and everything else are highly correlatable. If you reveal those things to your providers, to the people who you need to interact with, they're able to capture that information and track you, right? So basically, the way that works, if I have an issuer who provided a claim, I went to one verifier, to another verifier. If they have the data that uniquely identifies me, even behavior data, fingerprints of my devices that I'm using, they can correlate it, they can collude and understand who I am and discover my real identity. On the other hand side, if I'm building my system such that when verifiers go to issuer to verify my claims and they provide some information about me that uniquely identifies me, then issuer knows who I'm dealing with, right? So if it's my bank, all of a sudden they know, oh, I'm talking to another bank. Maybe I don't want that. So you need to avoid sharing PIIs if possible, but if you need to, just make sure that your users understand that, you know? So it's not a given. And if technology is sound, the privacy is not a given. So how does this work? So it's based on a wonderful technology that was pioneered here in Switzerland called attribute-based credentials or anonymous credentials. And basically the way that works, there's a bit of math there, is that as a holder, I interact with my issuer. I have an ID with them or session key. I provide my blended master secret. In other words, they cannot understand what it is, but they know it's a certain number. And then they provide credentials to me saying, okay, for this session key, for this identity, these are the attributes we provide something called CL signature for. And CL signature is a very specific technology created by Kamenets Lisinskaya, actually here in a research center of IBM. It has wonderful properties that later allow you to basically then take subset of its attributes and provide it to different verifiers. You use different, of course, identity because you don't want to be tracked, right? And then you provide a zero-knowledge proofs that, in first case, you say, like, issuer with a public key vouches that the attributes in green, I'm giving you access to these attributes in green A2, but I'm actually not giving you A3, but I'm just saying it's not equal S, whatever that is. And for the other guy, I'm reusing the same proof, but I'm using the same credential, but I'm using a different proof, whereby I'm just revealing, okay, attribute A1, but attribute A4 that you don't know is more than N, right? So I can do these things. I can even combine attributes from multiple issuers and create composable proofs, right? And they're unlinkable and untraceable because these proofs are statistically not related, right? So that's a very important concept there. Hopefully it all makes sense. So switching gears a little bit, talking about how to build applications. So if we use all that wonderful, interesting technology, what can we build? And basically, you can kind of think about identity applications and put them into different buckets. One bucket is what I call identity is key, whereby you're just using identity to get access to something. You prove you're entitled to something. And that includes loyalty and reward cards, access control, travel mobility, financial services, content consumption. It would be wonderful if I buy a song on Spotify but can use it on Tidal, for example. That would be great. And then, of course, there are much more complex applications whereby you're actually changing attributes of identity as results of the application itself. And there's lots and lots of interesting use cases there, buying, selling cars, property, healthcare because of health records, maintenance, information about my car, training and education, and so on and so forth, that are actually very complex. So just to give you some of these later examples, because the first ones are, I think, very trivial, already given one. Identity is content. We can actually build some of the systems even without DLT, right? Because if we can provide information that has some trust element in it, right? We can basically build this chain of trust. And for example, let's take anti-counterfeiting, where we want to build a chain of custody. So the first step, right? And let's talk about drugs, for example, right? So you manufacture some drug, you distributed them, and then people fake them, so you want to prevent that from happening. How do you prevent them from happening? Is basically want to make sure that only authorized people handle it, trusted people, and they have stake in the system. If they game the system, if we discover them, we kick them out, so they lose their business. Well, so they probably want to be honest, right? So, and then you can create hierarchy of authorized handler claims using the technologies as talked about. And what's interesting, as a manufacturer, I authorize my big regional distributor. Big regional distributor then goes to a smaller region, authorize somebody there, and finally they go to the delivery guys and authorize them, right? So we have this chain of claims that people can present, say, yeah, we actually have been authorized to do it. Now we ship a package, so manufacturer creates a shipment of medicine. You know, it creates a package, the ID, so it has its own identity. And by the way, identity doesn't have to be public identity on the registry. You can still use private identity as well because of micro ledgers, or maybe it's peer-to-peer identity, so you don't always need to put it on the ledger. So we have a package with identity. We give it to our authorized regional distributor. We create a claim about that, of that transactions on both sides. Everybody confirmed that they received the package with such a serial number and so on and so forth. Then the handoff happens. At each handoff, we create handoff claims. So everybody agrees they received the package and send it off. And finally, it gets to clinic, which is also authorized and known to the manufacturer. So at the clinic, basically, we can take all this different history of claims, which we created because it's a chain, right? And send it back to the manufacturer and verify, are these authorized people? Is that the right package, right? And if it's not, if something else happened to it, we know where to look, essentially, right? So it creates a lot of traces there. So it's possible without DLT. Maybe the connectivity is not good. Maybe it doesn't warrant a DLT use case, but with DLT, it just becomes much, much, much easier, right? So, but there are actually use cases where you have to orchestrate a system. Let's talk about some personalized medicine, for example. So as you know, now people work on personalized medicine, whereby I need to come to a doctor, maybe it's a cancer treatment. They need to diagnose me and say, well, actually this guy or girl or a child will benefit from personalized medicine treatment, so we need to send them to a special lab that will obtain blood cells of a certain quantity, then send these blood cells to a manufacturer. Manufacturer will process these blood cells, put them in a cryotank, shipment to the right treatment center, and we need to make sure that there's somebody paying for it because it's a very expensive procedure. So we need to involve all different players, from the doctor to the patient, to the insurance provider, to the manufacturer, to the special lab, and of course you want to have a market for it, right? So you want to track it. So how do you do it? It's a very, very complex application. And to me, complex application, they need combination of technologies. So you can use specialized ledger, like Sovereign, for example, that manages self-sovereign identity, and that information, my medical record, my consent, information about the receipts stays with me, right? And stays with this, isolated silos. But then I can, I can model the rules in information and interaction between this complex system that we need to orchestrate on a DLT. Maybe on Corda, maybe on Hyperledger, maybe on Aetherium, and so on and so forth, whatever is your fancy, and then use the identity information to orchestrate the system. And I think it's a very important pattern to understand, because it doesn't have to be just one ledger. You have to combine ledgers. What about payment? We can integrate something like Stellar in here, or and others, or maybe Aetherium, Interledger, other different things. And then you have a complete ecosystem that deals with identity, but deals with state, business rules, payments, and everything else. So this is how we like to build our applications and think about approaching this complex topics. So with that, I would like to close and say that obviously self-sovereign identity is key to scalable use cases. Please don't reinvent the wheel. Look out for the standards. Try to participate in them. If you don't like something, contribute back. Connect to your local communities. Certainly would like to have you all part of Crypto Valley, part of our working groups, interacting with other people. Be mindful about GDPR and PII. Those are things that will bite you if you don't care for them. Actually very, very complex to deal with. We earlier heard from Professor Bohannon that even proving to lawyers that you destroy the key is a challenge, right? So you need to be aware of that. And of course, identity is more than just a name and address, right? You can think about all kinds of different use cases, actually identity use cases, the attributes that you need to prove to different people. So thank you very much for your attention. I hope that was useful. Thank you.